Good afternoon, ladies and gentlemen. My name is Michaela Bledsoe, and I'm joined by Caitlin Miller. Thank you for joining us today for our presentation over cover crops and crop rotation. In this presentation, we will explore cover crops and crop rotation as essential practices for sustainable agriculture. We will discuss each topic, provide you with some practices you can use in your own operation, and have the opportunity to see these practices in application on our upcoming tour. Let's dig in. Cover crops are an agronomic crop grown with a purpose beyond immediate harvest. They serve as a strategic tool to manage soil retention, health, and quality. By suppressing weeds, pests, and diseases, they contribute to the overall health of agricultural ecosystems and can mitigate economic and yield loss for producers. Additionally, cover crops offer a myriad of benefits, including enhancing soil fertility, fostering biodiversity, and providing crucial support for wildlife populations. North Texas has a few staple cover crops. A popular option is winter wheat. Producers like to use it because during the winter months, when many fields would otherwise be bare, winter wheat serves as a protective blanket over the soil, reducing the impact of rain and wind on the surface, which protects from erosion. It also adds organic matter to the soil through the decomposition of its plant material. Crimson clover is another choice. As a legume, crimson clover forms a symbiotic relationship with nitrogen-fixing bacteria in its root system. This allows it to convert atmospheric nitrogen into a form that plants can utilize, thereby enriching the soil with nitrogen, essential for production. It also has a deep thatch and shading capacity, which helps suppress weed growth, which preserves resources for primary crops. Additionally, their flowers attract pollinators and beneficial insects, which helps with pest control and pollination efforts. Similarly, hairy vetch is also a nitrogen-fixing legume. It also has an extensive root system, which aids in soil structure by increasing the organic matter. Their root system increased infiltration rates, which prevents frequent runoff, which in turn mitigates erosion effects. Radishes are another option for producers. Radishes have a large taproot, which aids in improving soil structure and its porosity. Their leaves also suppress weed growth, which retains resources for primary crops. Furthermore, their large roots create a tilled channel for the subsequent crops, which improves their root growth and nutrient uptake. Crops play a crucial role in enhancing soil health. For example, they can increase soil organic matter, improve soil structure, and enhance microbial activity. In fact, according to SARE, cover crops can increase organic matter anywhere from 4 to 114%, depending on the crop selected. They also facilitate nutrient cycling by taking up nitrogen from the soil and releasing it back when they decompose. This reduces reliance on synthetic fertilizers, which often contains high levels of salt. Additionally, cover crops act as a natural weed suppressant, reducing the need for herbicides. Without cover crops, we risk experiencing similar conditions as seen in the Dust Bowl era. Erosion control becomes compromised, leading to widespread soil loss and degradation as seen in the dust storms of that era. Moisture retention decreases, intensifying water loss and making agricultural lands more susceptible to drought conditions. Furthermore, the absence of cover crops contributes to a decline in biodiversity, resulting in the loss of soil life and ecosystem functions. Understanding these consequences further highlights the importance of integrating cover crops into agricultural practices so we can prevent these potentially harmful outcomes.
We can combine cover cropping with other sustainable practices such as crop rotation. Crop rotation is defined as the practice of growing a series of dissimilar types of crops in the same area across sequential growing seasons. This means you would plant a family of one crop, such as grains or brassicas, for one season, and then the next season you would plant a different family, such as legumes. This rotation helps maintain soil fertility, breaks pest cycles, and reduces the buildup of diseases associated with continuous monocultural cropping. It does this because you are eliminating a consistent food source for a particular plant, or varying the nutrient uptake demands. So let's talk a little more about these benefits. Firstly, by breaking the pest life cycle through alternating crops, we reduce pest pressure and minimize the need for chemical pesticides. Secondly, crop rotation optimizes nutrient use efficiency by diversifying nutrient needs among different crops, preventing the depletion of specific nutrients in the soil, and promoting overall soil fertility. Next, the practice reduces soil erosion by diversifying root systems, which enhances soil structure and improves its ability to hold soil in place, ultimately mitigating erosion rates and preserving valuable topsoil. Lastly, alternating crops, we reduce the concentration of specific pathogens that thrive in a single crop system, thus lowering the risk of disease outbreak and the need for chemical interventions. This reduction in disease pressure contributes to overall crop health and resilience, promoting sustainable agricultural systems that are less reliant on pesticides and fungicides. All of these benefits translate to cost savings and increases in yield for producers as well. So, what might crop rotation look like? We have traditional rotations. This is the conventional practice of rotating crops in a specific sequence over time to manage soil health, pest pressure, and nutrient levels. An example of a traditional rotation is the sequence of corn followed by soybean followed by wheat. Next, we have cash cover crop sequences. This involves integrating cash crops, those grown for sale or profit, with cover crops in a sequential planting pattern. For instance, planting corn as a cash crop, followed by planting crimson clover as a cover crop. Lastly, we have relay cropping. This method is where two or more crops are grown at the same time in the same field, with one crop being planted before the other is harvested. For example, soybeans may be planted while wheat is still growing, allowing for crops to be grown in tandem. These methods are employed by farmers to optimize yield potential while maintaining soil health and sustainability. At the Kittner Farm in the southern high plains of Texas, Kelly and Deborah Kittner implement a strategic crop rotation and cover crop system to enhance soil health and adapt to the region's climate challenges. Their rotation begins with planting small grains such as cereal rye, which is followed by sowing a warm season cover crop with the mix comprising of pearl millet, cowpeas, and sun hemp. This combination helps protect the soil and promotes microbial activity during the summer months. They follow this with cotton in the sequential growing season. After harvesting cotton, they transition to planting a cool season cover crop mix, including cereal rye, barley, winter pea, black oats, and daikon radish. This rotation not only mitigates wind erosion but also maximizes moisture retention, fosters soil health, and enhances sustainable agricultural productivity in the face of changing climate conditions. Implementing cover crop and crop rotation practices comes with its set of challenges that require persistence and adaptations to overcome. One major challenge is adapting machinery and equipment for cover crop planting and management due to differences in crop types and growth patterns. Additionally, knowledge gaps regarding cover crop species selection, planting techniques, and management practices can hinder implementation efforts. Fluctuating market demands for cover crops and rotation crops further complicate decision making for farmers. Moreover, initial investment costs and uncertainties surrounding returns on investment are financial challenges. Despite these obstacles, persistence, adaptation, and ongoing learning are essential for successful implementation. Overcoming these challenges requires innovative solutions, and a commitment to achieving sustainable agricultural practices. Welcome to the end of our presentation. It is important to highlight the takeaways from our exploration of cover crops and crop rotation in sustainable agriculture. These practices are essential when it comes to maintaining sustainable agricultural practices. These practices contribute significantly to soil health, biodiversity, and overall resilience in our farming system. However, it's essential to recognize that adapting cover crops and implementing crop rotations isn't always straightforward. It requires a deep understanding of the challenges involved and a strategic approach to overcome them. So, what can you do now? Further explore these topics and work to implement some of these practices into your own operation. By doing so, we can actively be good stewards of the soil while having the plants and soil work for us to decrease input costs and improve yields. Sustainable farming isn't simply a concept, it is a necessity for our future. Cover crops and crop rotations are amazing tools you can use to improve the sustainability of your farming practices. Let's put these concepts we discussed in action. Imagine you are a farm manager and you just harvested your traditional corn crop in August. Following that harvest, you typically leave the field fallow, nothing growing on it, with only corn residue covering the soil throughout the winter months. In April, you know it is time to fertilize and replant with corn once again. However, you notice that this cycle results in a staggering 7 months without any living soil cover. Knowing what you know now following this presentation, what would you do differently this growing season? With such a significant period of fallow time, what cover crops would you choose to plant to optimize soil health, biodiversity, and the overall resilience in this scenario? Let's group up and break out to discuss. Here are some questions to think about. What cover crops would you recommend planting in this scenario to improve soil health? What strategies can we implement to enhance the resilience of this agricultural system? We will join up afterwards to share your ideas.
You all did great with that scenario. We are very lucky that we have the opportunity to visit the Barton Springs Mill Farm to hear about their experience with cover crops and crop rotations. After the farm tour, we have also arranged to see the mill and end with a cooking class. We are seeing a rare agronomic farm to fork experience. Thank you again so much for your time today. See you on the farm. If you are interested in reviewing the sources for this presentation, please see the references on this slide. Thank you.